Hello everybody, it's Coach Razo here. In this video, what we go ahead and discuss is the unit of logic. And the way that I want to present it to you is by the idea of the scene of Iron Man 2, where they're trying to go ahead and take his Iron Man suits away from him, and he's coming up with all these reasons of why you can't do it. Now, that being said, so I want you to Iron Man up. So I want you to have that kind of role when you're trying to, that kind of mentality when you're trying to solve these problems. So it's not necessarily solve for X every single time, but you just have to identify them. Now, from here, we're going to be using something called inductive reasoning, conjectures, and counterexamples. So make sure you're lowering up because that's what we want to go ahead and do. So inductive reasoning is reasoning when it uses a number of specific examples to arrive to a conclusion. So if I say example 1, example 2, example 3, so far, and I say my first example is 10, my second example is 20, my third example is 30, and the question is, hey, what's going to go ahead and continue? If I continue this pattern, what's going to be my next pattern? So you have these values that you are given. So in this way, it will be considered maybe 40 that you're probably thinking. So when you assume the pattern, when you assume that an observed pattern will continue, you can apply inductive reasoning, which is what we just did. The concluding statement reached using inductive reasoning is called conjecture. So if you were to go ahead and give me a statement based on these patterns, so you have to go ahead and come up with a sentence where it's proving this. So what's happening every single time? So are we multiplying? Are we adding? Those are kind of questions that, or multiplying, dividing, whatever it is. Those are the kind of questions that you have to come up with your head. So we're adding 10, plus 10, plus 10. So if I need a conjecture, which is a statement for this, my conjecture can be is that the next term adds 10 from the previous number. Okay. Now, I'm not saying that this is going to be the absolute final statement, but you have to come up with your own. So you have to be creative at some point as you're going. So this is kind of the way that I understand it in my head for this example. So maybe somebody can write something a little bit different, you know? Okay, so moving on. So the more examples, the better, guys, okay? So find counterexamples. Okay, so to show that conjecture is true for all cases, you must prove it. It only takes one false example, however, to show that a conjecture is not true. This false example is called a counterexample. So it can be a number, a drawing, or a statement. So you have to be creative in terms of what you're drawing, and you got to come up with numbers. So whether it's 9, a -2, and a 5, or maybe like an 11, -11, you have to be creative in terms of like which numbers to go ahead and use. Now, the most basic numbers are usually 0, -1, and +1. So I'm just throwing it out there for y'all. Okay, so a counterexample. So let's say I'm thinking about boy names. So if I'm trying to go and come up with boy names, and if I say a statement where every single boy's name is John, so every boy is named John. Okay, so that would be considered, this would be my example, okay? So problem 1. Now, from here, is that true or false? So if some of your thinking is true because your name is John, or maybe some of you are thinking false because your name might be Edward, or it might be Eddie, so that's false. That's a false claim. So this is false. And then why? Because my name is Coach Razo, so it's not John. So every boy's name is false. Give me a name. I'm going to say Edward. Edward is a boy. Okay, so you got to be creative in terms of like when you're looking for answers. So always think of one person. So it takes one to ruin it for everybody, right? Okay, so we're gonna go ahead and we're going to go ahead and look for examples here. So make sure you're being creative as we're on. Okay, so on this one, so we call this number 1, call this number 2. So find the next term in a sequence. So I know that's +2, that's +6, that's plus a big number. Okay, so I'm going to go ahead and try to just keep it simple for myself. I'm going to go at times 3, times 3, times 3. Look at that. Okay, so sometimes you might have to go ahead and like move guess as you're going, and so you can go ahead and get to the next term. So as long as you can find a pattern, make a statement with it. So find the next term in the sequence. So my next term in the sequence, I'm going to use my calculator, will be 81 times 3, which is 243. Okay, so that's my next term. So sometimes you'll have like some of these like where they ask you for a value, which is great because they'll be like the most probably basic ones that you have to work with. Now, another one is going to ask you to write a conjecture. So in this one, it didn't ask for it, just asked for the next term. And this one is asking to go ahead and write a conjecture that describes the pattern that we see, and then use your conjecture to find the next item in the sequence. So if I go through here, and I'm going to write these down so I can go ahead and let's just do it. Nobody. So I got 2, I got 4, I got 12, I got 48, I got 240. Now, if I'm trying to go ahead and get from 2 to 4, 4 to 12, and so forth, I'm going to see if I can find a pattern. So I'm going to do a trial and error. So I'm going to times 2 times, I can't do times 2. So I'm just going to go ahead and go with times 3. And that gives me 12. Okay, great. So if I know it's times 2 times 3, my next number would be maybe times 4. And so I'll put times 4 in here. It actually worked out. So go to the next one, times 5. And I'm going to check that one. 48 times 5 gives 240. Look at that. So if I'm looking for my next one, times 6. And so my new value will be whatever that is, times 6, and now I got 1440. So 1,440. So that I found my next value. So so my next item in the sequence is 1440. Now I got to write conjecture. So I'm going to go ahead and come up with, I don't know, the next term will multiply by +1 of the previous example. Okay. Now, like I said, some people may write it differently. So some of you may understand it this way. Another way to go ahead and understand it, let me see. Another example. Kind of like this one. So we can use this one as well. So the multiples between each term increases by 1. So the next term is 1440. So a variety of people can be different in the way that they interpret it. But as long as you can go ahead and state your claims and what it is. So this is where, and like I said, like every lawyer is going to be different. They're not going to be the same. So I'm expecting every single one of you maybe come up with a different example. But as long as you can prove your claim, you'll be okay. There you go. So so be aware of it. So some of you may like this one, or some of you may like this one. Okay, so the multiples between each term increases by 1. So the next term is 1440. So that's one thing, and they're like, and they're also a sentence stems too. So the multiples between each term, or the first difference, or the second difference, and I'll show you those in a little bit. Okay. Now the next one. Okay, so write conjecture that describes a pattern in the sequence and use your conjecture to find the next item in the sequence. Okay, so I have 1, I have 3, I have 6, and I have 10. And so if I'm trying to figure out the next one from here, okay, so I know that's times 3 times, oh, okay, so multiplying doesn't work out this one. So let's go with +2, +3, +4. Oh man, so that means that the next one could probably be +5. So you probably end up getting, let's use a different color for that one. So you probably end up getting a +5 here, and then you probably get 15. Okay. So now this is the next term. So that's our answer that we're looking for. So that's my next term. Oh, next item. Okay, now from here, this is called the first difference. And it's just what it sounds like. So like adding, subtracting, difference means subtracting. So just be aware that sometimes these will come up, or you will need to go ahead and multiply. So always understand these are going to be different. There you go. Okay. Now that's considered the first difference. Now, if you're trying to look for the second difference, you can do that too. So second difference. So if you notice these are already adding and so forth, and you see that there might be a little bit pattern where they're different. So let's go with green. So from here to there, it's +1, +1, +1. Look at that. We have a constant. So this constant is what's changing every single time. So that's an absolute truth right there. So after going with this, we got to come up with this is our final answer. We have to come up with a conjecture. So we can say that the second difference is +1 to reach the next term. We can say that one. Or we could say that the first difference is +1 to reach the next term. Okay. So then I'll have 15. 15 is next. Okay, so some of you might be is the next term. So this is where I'm saying that you can go ahead and have you have to be able to write. So is the next term. Okay, so let's see what else I got over here. Okay, so how's it going? So boom, right here. So we also come up with this example as well. So like I said, there's going to be a variety of different ones that you can explain it. You can go ahead and explain it as. Okay. So in this one, it was that the second difference. Use a little picture along the way. So the second difference is increasing by 1. So the next term is 15. So ideally, what it is what we it's pretty much what we have, except I put the +1 here. Now, just be careful is when you're writing these, so you understand, as long as you can understand what's going on, and then as long as you can interpret it so somebody else can read, and from like a different country or from a different school, then it's good to go ahead and use a variety of different examples. Okay, so just so you can see what it looks like. Okay, so just be careful as you're doing these because it does get a little bit tedious. Okay, so work out a few of these and then we'll go from there. Okay, so if I can go ahead and work on number 1, I have a 3-sided shape, 4-sided shape, a 5-sided shape. So what's my next shape? And if you forgot, it's a hexagon. Okay, so just throwing it out there for you. So next one, if we have 3 to 6, and we have 10, then that'll be plus 3 plus 4 plus 5. So this will be 15. Now, in this one, it's asking you to determine the next term in the pattern. So you're not asked for a conjecture in this example. So you just want to be careful on how to find the next value. Now, some of them will be a little bit all over the place, so you just have to go ahead and just trial and error as we're going. So from 7 to 14, you put plus 7, plus 7, plus 7, so this will be 28. Okay, so just be mindful of it. All right, so over here, close to the end, guys. Okay, so in this one, counterexamples, you got to play lawyer again. Yeah, Iron Man up. So in this one, if it is the weekend, then it is Saturday. So that's true or false? That is considered false. Okay, so you're asked to provide a counterexample to prove each conjecture is false. So in this way, it could be Sunday. So it can be Sunday. So that's the one we have. Now, conjecture, all birds are blue jays. So somebody's saying this. Is that true or false? It would be false. Why? Because you can see eagles. Okay. So just throwing it out there. Okay, so as you know with the numbers, what's best to go ahead and use is maybe come up with a number in your head. So think of numbers. Think of numbers or random numbers. Now from here, let's go with number 4. So if a number is less than 10, then it is less than 9. Is that true or false? So give me an example. So that's less than 10. So a number that's less than 10, I'm going to be thinking maybe like, let's go with 3, 4, and then I'm going to say 10. Then it is less than 9. So that means for 3, that's true. It is less than 9. For 4, that's true. But then for 10, it's not true because 10 is less than 11, but it's not less than 9. So that means this is false. Okay, so you can pick number 10. Okay, so just throwing it out there so you can see the examples. Okay. Now, as you're going through these, you might have some negatives and positives. So number 7, the sum of a negative number and one positive number is negative. So let's think about this. So if I have a negative, and I say negative 1, negative 2, and negative 3, and I have to add, because it said sum, I'm changing my color here. Red. It said sum. So if I have a negative, like negative 1, 2, and 3, plus a positive number, which is green, I'm going to say 2, I'm going to say 3, I'm going to say 4. And I know I'm making these up, guys, okay, as I'm going. So these are positive. Okay, so that means they have to be negative at the very end of it. So if I say negative 4 plus negative 3 plus 4 gives you a positive 1. Negative 2 plus 3 gives you a positive 1. And this one gives you a positive, oh, look at that, positive 1s. So the sum of a negative, sum of a one positive number is negative. So that would be considered false. Because why? Because I picked a negative number, which is like -1, and then one positive number, I picked +2, and they happen to be, when they add them, becomes negative, becomes a +1. Okay, so that's my counter example right there. So I'm gonna say -1 and 2. So you have to be creative when you're trying to pick these numbers out. So the more practice, the better, guys. Okay. So just be careful as you're doing it. Or if you happen to get one of these, you can go ahead and pick out the same value too. So let's say I'm going to test it out for 2. For let's change it up. Let's go with change it out with 1, 1, 1. Okay. So that's my negative number on the left, and that's my positive number on the right. So when I go ahead and combine them, -3 plus 1 becomes a -2. That makes my statement true. -2 plus 1 gives you a -1. That makes my statement true. And so -1 plus 0, that gives a -1 plus 1 gives you a 0. So that makes it actually false, because these two happen to be my true cases, and this one happened to be my false case. Okay, so that's true, and this is my false. Okay, so you have to be creative in how you're moving numbers around. Okay, all right, so I think I'm gonna leave it there, and then I'll let you go ahead and see if you can figure out the rest on your own. Okay, all right, have a good day, guys. Tune in next time for the next video.